Welcome back to our grade 10 maths lessons. I am Miss Awinup, your maths teacher. In our last lesson, we looked at tangent and chord properties in a circle. Okay. In today's lesson, we are going to look at deductive reasoning. Okay. Deductive reasoning. Okay. Now, this is in terms of circle geometry. Now, you will notice we have a few diagrams to the right of the board. We will get to that. Okay. Deductive reasoning is, or it means simply to think it out. Okay. So thinking it out, meaning you have to use logical reasoning to get to your answers. All right. So we're going to see how to apply deductive reasoning with circle geometry. But first things first, we need to review our circle properties. Okay. Now, you will notice we have 7 diagrams. The first 3 diagrams or circles show chord properties. Okay. So we will go through that very quickly. Now, remember that diameter is a chord. So if I have a triangle formed together with that diameter, it will form a right angle triangle, indicated by the symbol at that end there. Okay, that's the first property. The second property, 2 angles formed at the circumference of a circle sitting on the same chord and the same arc are both equal. Okay, the third property states that if an angle is drawn at the circumference, that angle is half of the angle here at the center. Okay, you can see our symbols show that this one here is half of this. Okay, those are the properties linked to the chord. Here, the next 2 circles show tangent properties. Okay, the first tangent property states that if the radius is drawn to a point at the circumference and meets the tangent at that point, it will form a right angle. Okay, you can see the symbol there shows that. That's property number 1. Now, property number 2. Look at our diagram. You will find a lot of markings there. Pay attention as we review this. If 2 tangents are drawn to a point outside the circle, all right, those 2 tangents will be equal. All right, that's indicated by the strokes on the lines here. All right. And in addition, if I have a line drawn from the center of the circle to the point outside the circle, this line here is going to bisect. It's going to bisect these angles here. All right. What does bisect mean? In our last lesson, you were told it's going to split into 2 halves. Okay. So this angle here will be equal to this angle. All right. The angles here, the center will also be equal. We can draw this in just to make sure you understand that. All right. So we have 2 triangles that are identical. Angles here and here are equal. Angles here and here are equal. All right. So those are the 2 properties in terms of the tangent. The 2 last diagrams show where tangent and chord are drawn at the same time on a circle. All right. So if we have a diagram as such, the angle between this chord here and the tangent will be half the angle at the center. Okay. The angle between the chord and the tangent is half of the angle at the center. Right? The last property, okay, shows a triangle formed by 3 chords, and we have our tangent. The angle between the chord and the tangent here is equal to the angle that is opposite the same chord. All right? Follow the arrows. The angle between the chord and the tangent is equal to the angle opposite the same chord. Okay? Works the other way as well. The angle formed with this chord and the tangent is equal to the angle opposite the same chord. Okay? Now, that was a very quick review. We've already done this. and we've already gone through examples. Now we're going to see how to apply deductive reasoning using these properties. All right, remember, deductive reasoning is to think it out. Okay, so what we will do, we'll start with an example to show how we apply these properties. Okay, I'm going to draw this very quickly. All right, we have a circle with a tangent. All right, this tangent is AT. All right, the center of the circle is marked with O. Okay, and we have the radius. All right, so given a circle with a tangent AT, all right, the angle between the tangent and this chord here is 40 degrees. All right, and we are asked to find angle BAO. All right. Angle ABO, and C angle AOB. Okay, now let's identify where these angles are. Okay, so we have angle BAO. BAO is this angle here. Then we have angle ABO, which is at the center. And then we have angle we have angle ABO, which is ABO, right here. And then the last one is AOB at the center. All right, so looks like we are looking for the angles in the triangle formed by the three chords here, the two radii and the chord AB. Okay, now let's put in all the information we know from our properties. Okay, so the radius, let's start with this one. OA and OB are both the radius. Okay, so they are equal. All right, and when that radius meets the tangent at the circumference, it's going to form a right angle. Okay, now what else can we put in? That is all. All right, so BAO, this angle here, how do we find that? If we have the two radii here, let's write this down. Line AO is equal to BO, which is equal to the radius. Okay, if the two sides of this triangle are equal, then triangle AOB is isosceles. All right, now we already looked at isosceles triangles. Isosceles triangles have this property: two equal sides and two equal angles, which means that this angle here, BAO, and the angle OBA here are equal. Okay, how do we find this? We are going to use the circle property where radius and tangent meet 90 degrees. So angle BAO is equal to 90 minus the given angle here of 40, which is going to give us 50 degrees. Okay, so we found angle BAO to be 50 degrees. All right, and because it is an isosceles triangle, all right, then angle ABO is also equal to 50 degrees. All right, BAO. So we found the second angle without even working out anything. That's what we mean when we say thinking it out, okay? So angle AOB, which is the angle at the center of the circle, can be found easily by applying the angle sum of a triangle, which is 180 degrees, all right? So angle AOB is equal to 180 minus the two angles 50 plus 50, okay? 180 degrees minus 100 will give us 80 degrees, okay? So using deductive reasoning, sometimes you don't even need to work out using numbers. No. Simply look at it, reason it out, thinking it through, and you will get to your answer. All right? So deductive reasoning is a very important skill to have. I hope you have learned something today. In our next lesson, we are going to look at how to apply these properties with algebra. Of course, we're still looking at circle geometry. I hope I see you soon in the next lesson.